For these arc trig functions, your inverse trig functions, you have to memorize certain formulas, and what you're basically trying to do is match it up to something that looks like this. Now, when you see a square root, you really should start thinking about one of these arc inverse trig functions, and in this particular case, what I would notice is that this 1 minus x squared, when the number is first, that has the structure of the arc sine function. So what you're really trying to match up here is this integral of du over the square root of a squared minus u squared. And what I personally like to do is, like, I know that the rule that I'm looking at is du square root of a squared minus u squared is equal to sine inverse of u over a plus c. So I write down that rule, and then I try to match up what I currently have. So if you look at what you currently have, your a would be equal to 1, and your u would be equal to x. And then your du, of course, would be equal to dx. So you have exactly it as set up with the current integral. You don't have to multiply anything in to get your du there. So this answer would be that this is the integral of sine inverse of u, which is x, over a, which is 1. And then because we have bounds, we'll have to put it from 0 to square root of 3 over 2. Okay, so you match it up based on the u, the a that you have identified, and then we will plug in our upper bound minus our lower bound plugged in. So you will have sine inverse square root of 3 over 2 minus sine inverse of 0. Now, when you're looking at identifying the sine inverse, remember what that really is it's equal to an angle. So this is going to be the question of what angle is going to be the sine of that angle is equal to the square root of 3 over 2. Specifically, when you're talking about the inverse sine function, it has to lie in this negative pi over 2 to pi over 2 region. So you're looking basically only at this quadrant 1 and quadrant 4, and you're asking yourself, okay, where is the y coordinate equal to the square root of 3 over 2? Now, that y coordinate, of course, is the bigger coordinate, square root of 3 over 2. It's going to be up here at pi over 3. So arc sine of square root of 3 over 2 is evaluating out to pi over 3. And then for your arc sine of 0, again, the same idea. You're looking for an angle. You're looking for an angle theta whose sine is equal to 0. Specifically, you're looking for where is the y coordinate equal to 0. And again, you're only going to look in this region from negative pi over 2 to pi over 2. And that is going to happen at the angle of 0. So this will be minus 0, and that just gives you pi over 3 as your answer.